All of you, welcome back once again. I hope you guys are enjoying this token staking Dapp project. In this video, we're going to write our custom ERC20 token without using any external library. So far you guys have used OpenZeppelin for building your ERC20 token, but in this we're going to build our own ERC20 token with more feature which we can use to fetch the data and display in the front end as per the user holding, as per the user transfer of the tokens. So that's the custom token we're going to design in this particular video. You have both the option. You can go with the normal ERC20 token approach with the using the library of OpenZeppelin, but I want to make it custom token from my own because I want to add more feature to it so we can perform more action in our Dapp. So let's provide the license identifier. Then let's write the contract. We'll say contract the blockchain coder. So this is the name of the contract I'm giving. You can give your name. Let's define a couple of variables. So we'll take a string public name. So this is the name I have given to my token. This is the symbol BTC. Let's give the string, which is going to be the standard. You can define any standard. This is the general standard which you have to follow when it's come to building any token. So if you look at the documentation of the Ethereum and the ERC20 token, these are the couple things you need to have. So this is the version of the standard I'm defining for my token. Now we'll take this total supply. We'll take the owner of the contract and we'll take the public user ID. Then we'll take this UNT variable. We'll take a constant and we have to say initial supply to be 10,000 and it's going to be an 18 decimal point. Okay, so this is the supply which I want to trigger to my token, and we can take the address public holders token. So in that we're going to keep all the addresses of the user who will have our token so we can display in our front end. Then we'll take this particular event. We'll say transfer from to and the value. Then we have to define our approve. Inside that we'll take the address owner and who we want to approve, the spender, and the amount we want to approve them to spend the token. So this is the event, second event we have. Now we can come here and we have to define a couple of mapping because we have to keep the track of the transfer of the tokens and who is holding how much token. So again we can display in our front end. So we'll take a mapping. We'll say address is greater than the token holder info, and this is the struct we have to build. So we'll build this token holder info. We'll take the UNT token ID. We'll take the address from. We'll take the address to. We'll take the UNT total token. We'll take the boolean token holder, and these are the information we are doing. So whenever someone will transfer any token from the contract, means I'm the owner and I'm transferring any token to anyone, so every time this ID will increase. So first we'll start with 1 2 3 and that's how we'll assign the ID, and with this boolean value we are checking that whether he is a holder of the token or not. Okay, now we have defined the second mapping, which is the address and UNT, the balance of the user in the contract of the token. Then we'll take this mapping called mapping address and it's going to return this UNT variable. Then we can come here, we'll take the constructor, and well, we have to simply update the couple of data. So we'll come here, we'll take update the owner. So we'll say message.sender means those who uploading the contract. So sorry, the person who is uploading the contract is the owner of the contract. Then we can come here, we'll have to update his balance to the initial supply because he's going to be the owner of all the token, and we'll take this total supply equal to the initial supply, and that looks pretty fine. That's the simple constructor we have. You can take it as an input at the time of deployment, but I will go with this hardcode data because this is the data I want to assign. Now we have to write a couple of functions. So first function is increment. I call it in, you can call it increment, and this will allow us to update our ID. Okay, so we'll say user ID plus plus. So this is the variable we have taken and it will increase. Then we can come here, we'll take a function called transfer, and then we have to pass the address value, and that we have to simply call as public, return the boolean, And first we have to check for a condition. We'll say required balance is the message of sender is greater than the value, means when he try to withdraw or transfer the fund, he has to have at least that amount of fund, otherwise we can throw an error message. Then we have to call this increment whenever the transfers take place, and then we have to simply minus the actual fund from his address to, and we have to update to the caller one, sorry, the person we are transferring to, and then we have to simply update the entire information into a struct. We'll say storage token holder info, and we have to pass the address, and that way we can map it, and then we have to simply update the entire information to, from, and we have the token, then we have the token holder info. It's gonna be a true because he will hold couple of token, and we have to update the user ID. So these are the information we are updating. Come down here, we'll take this token holder, and we have to push the address because we are keeping the address in an array, so of all the users. So that looks pretty good. Now we can initialize our event, transfer event, pass the address and the value. Then we have to simply return this true after the successful transfer. Hope you guys have understood that what we have done. That's a very simple logic we have implemented. Now let's move to the second function. So we'll say function approve. It will take the address, then the value, public. It will return the boolean if the approve is successful. Then we have to allow this message spender, and we have to map it. Okay, we are calling this allowance message.sender to spender and the value. These are the information we are getting. Then we have to initialize our event, and that way we can approve, and we'll return this true. That's a pretty simple one. Then we can take this function transfer from. We have to take this couple of things. We'll take the address from to, and we have to take the value, and it's going to be return the boolean success. We'll take this required value should be less than the balance of the from, means there, and then we have to do another check. The balance should be less or equal to the allowance balance sender. Then we have to simply take the balance of, and we have to subtract from the transfer, and we have to simply update to whom we are transferring. So that's how we can update the balance and deduct the balance. Now we have to simply call this allowance, and we'll have to refer to the balance so we can deduct from his, because we have approved that person to transfer the fund on behalf of us. So we have to make the connection, and then we have to deduct the fund from this person who have approved, and then we have to call this particular transfer event, and we have to return this true. You can define custom message, but I'm going to return this true or false. Let's come here. We have to take this function called get token holder data. So this will give us the information about the all the user have to the done the transfer or holding tokens. It will take the address. We'll say public view, and we're going to return the, let's say, unt. It will return the address, all the data we want to return, and address, unt, boolean. So these are the information we have here. Let's close that down. Come here, let's work on the logic. So first we have to return the token holder info. We have to pass the address, the ID, and that address to, and then the from, then the token value information we have to withdraw, total token, and then the status. Okay, so these are the data we are passing. Pretty good. Now close this one. So this will give us the information about the individual if you pass the address, and what is the status of him in the contract, ID, token, and whether he is the holder or not. Then we can take this and get token holder, and it will return the address, and it will return the entire array of the token holders, all the user. And that's the custom token we have written. Hope things are entire making sense to all of you guys that what we have done. Don't need to worry, everything will make sense when we'll try to bring all the functionality together. So this is the transform one. That one is a pretty huge one. Then we have the approve, then we have the transfer from, and we are building all the logic. This is the data for getting the data from the contract, and this is the holders, token holders. That's pretty huge. So that's the only thing I want to cover about this custom ERC20 token with the custom logic we have implemented for fetching the information. And I believe that you guys have understood that how you can write that without using any external library. In the next video, we're going to work on the token staking contract, and this one is the main contract because whatever contract we have built internal contract, and we're going to use it those contract as a library in our main contract in the token staking, and that's what we're going to work in the next video. So make sure to watch that video. That will make you more sense, and it will teach you a lot of new things that how you can build the actual real world contract. So let's move to that.